Okay, our next video is line 18A 3E, accelerometer, step, SQUID, newtons, force, 1G, UFO, speeds, Wow Seti, and it's part 109. The accelerometer, step the satellite test of the equivalence principle, superconducting quantum interference devices, and 9.80665 newtons of force per kilogram of mass, which equals the 1G speed. Based on the Wow Seti signal. And an accelerator is a device that measures proper acceleration. Okay. Testing equivalence on 1 to the part in 1018. This came up, it was some sort of test that they were doing. And it uses nearly the full gravitational acceleration of the Earth, and the masses fall for a long time. The large gravity by itself would result in a signal about 1,000 times larger than that, say, in Dickey's 1963 experiment, which used a much smaller acceleration toward the Sun. Second step will operate in the extremely quiet environment of a drag-free spacecraft. The total gain after taking into account the size of the remaining disturbances is about a factor of 10 million over Dickey, giving an expected sensitivity of 1 part in 10 to the 18. That's what that looks like. This is the concept of step. Unlike a free fall from a tower, a free fall in orbit continues indefinitely. Any difference in acceleration that is an equivalence principle violation can build up displacement for a long time. The buildup increases the signal relative to any noise, and the periodicity gives it a characteristic signal. And the step masses are constrained to move along a straight line by frictionless superconducting magnetic bearings. And then I found this graph here. A combination of electric and magnetic fields will position the masses and allow us to make accurate measurements of some internal disturbances, such as electrical charges on the masses or static background forces. And this is explaining what it is. And then we have the superconducting quantum interference devices. The squids used for step are DC squids, which in their simplest form comprise a superconducting ring broken by two very narrow insulating gaps. Current is injected into one half of the ring and removed from the other. The output is the voltage that develops across the gaps. Okay. And here's some stuff here. You got the photon wave function, optical interferometer, and then the SQUID interferometer. And this is the pattern shifts member of the flux quanta. No idea what it means. Okay, so it talks about electrons, magnetic flux, quantum interference patterns. So my thoughts for line 18A3B. We just found out some interesting info in theory. They say constant linear acceleration can provide short flight times around the solar system. That's in the line 18A3B video, okay? So now we know what all that linear data is probably about and how to do it. Quote, constant linear acceleration could theoretically provide relatively short flight times around the solar system. My thoughts continued. If a propulsion technique able to support 1 gram of acceleration continuously, a spaceship accelerating at 1G would reach Mars within a few days. If a propulsion technique able to support 1G of acceleration continuously were available, a spaceship accelerating and then decelerating for the second half of the journey at 1G would reach Mars within a few days. Okay, so my thoughts continue. So the question here you ask is to ask this. Which mathematical equation, lines of data, can we use to figure this out? How to support 1G of acceleration? Look back to the alien contact messages where the mathematical equation talks about velocity. I'm assuming this is the key to the whole thing. So I googled a G acceleration to see what speed it needs, and that's when I found out about the 1G. It's the acceleration due to gravity at the Earth's surface. So that's the speed that we need to go. It's 9.80665 newtons of force per kilogram of mass. Okay, so February 4th, my thoughts continued. This is just a simple example of the mathematical equations one uses to find a rocket peak altitude and motor delay. I don't know what kind of formula NASA uses. I just wanted to see what it looks like out of curiosity. So I googled it, and this is their calculations here. And M is your rocket mass, G is your acceleration of gravity, A is the rocket cross-section area, drag coefficient, air density, motor burn time, motor thrust, motor impulse, burnout velocity, altitude, coasting distance. So there's a lot involved with it, I guess. So there you go. This is from a website, myexecp.com. Rocket equations. So I googled rocket equations to find out how they figure it out. So that's that video there. Okay.